and they free spin when you take those screws off the top, and you'd be surprised at how little there is any pressure or anything in there that holds those platters in place. But the problem is this cylinder, because the data that's written, and especially the servo information that's going to matches from the top of the board to the bottom to the, each platter is exactly aligned above each other. And if it was moved even like a 0.05 microns, it would never line up again, and you would never read the data off of that drive, because the piece of data is written on top, and then it's written on the bottom, and then it's written on the top of the next platter, and that's what makes up this cylinder that you always hear, cylinder head, blah, blah, blah. And so that's where that information, if the two platters is turned, that's it. It's all over. You will never be able to read it again, at least not without some really, really extreme measures. So the voice coil is down here on the end of the arm of the hard drive's head. And the voice coil works exactly the way that the speaker does. Basically, it's putting an electrical pulse through the tail, and it causes the arm to move back and forth over the location of the platters. So that's one of the reasons why, because it moves so fast and it moves to a certain location that we can't tell, like we did with the stepping motor, where things are, and that's why the servo information is there at all. So this is the way that this works, and basically the magnets are pulling it in one direction or another, causing that head to move in extreme fashion back and forth. And this head can move back and forth over the platters 60 times per second. That's much faster than the stepping motors that we had up until about 1989. And Seagate and several other manufacturers were still doing that up until 1989 before they switched over to the voice coil that we use now. The air pressure, basically the way that this works is the head of the hard drive used to actually sit on the platter. In the early 1950s, when they first made the hard drives, the IBM made them so that they had tracks on each side of the heads, and it sat on the platter and scraped along the platter on the orange stuff, which used to be the iron oxide. It's basically rust on the platter. So you can imagine that as the head was moving over the platter, if there's rails and they're touching the platter, eventually it's going to cause a lot of wear and tear, and these drives are going to go bad. And these things you would have 24-inch platters, and there could be 50 of them in one hard drive. And so when one went bad, it was extremely costly and extremely difficult to get in and replace one and get one running. So basically, through an anomaly, one of the guys figured out that when the platters are spinning fast enough, if you took some of that weight off of the head, it would actually float over the platter. And so by 1963, they switched over to having a head that floats over the platter, and it's never gone back since then, because it basically eliminates that whole wear and tear that would actually happen on the drive. So when you hear that a head hit the platter and you have a crash, sometimes it doesn't actually cause a crash, but it can physically scratch the platter and do things. Most of the time now, when a head hits the platter, what actually happens is the head itself gets damaged because it's a small piece that sits at the end. This is the way we basically write data on a platter at this point in time. We use this longitudinal recording mechanism, and this has been in existence for 50 years up until basically this year. This past year has been the first time that we've actually had drives that were introduced that were different than this method. So it hasn't really changed over time at all. The only thing that has really changed is the areal density of the drive. So as we've increased the amount of space that we can write data on, it starts to cause this problem where you get bits that are flipping, and that's called the superparamagnetic effect. And they've known that this was going to happen. They continually do math to try to predict when the bits are going to get messed up, when they're going to flip. And this gets beyond what the ECC data can recover from. When the ECC data is reading this, if there are too many flip bits, it will not be able to read this at all, and you'll eventually get a drive that just can't read anything. It'll just completely mess up everything that's happening. So this is the new drives, like that new 750 gig Seagate that just came out. They just switched over to a perpendicular recording mechanism, which instead of writing them long, it writes them up and down so that you can read the data and have more density in a smaller amount of area. Their goal is to make it so that your drive can spin faster, the head can read faster, and that your data is still intact, whatever the way that they're going to do it affects the drive. So they've switched a number of times to different mechanisms, and they use glass platters. Some of the drives use glass platters, and some of the drives use aluminum. And so they're trying to basically make them lighter and thinner so they can spin faster, and then they increase the density and also go to this perpendicular recording mechanism, and that's how we get a drive that has a single platter or just 2 platters at this point in time. That's typically the maximum. I've seen a few drives that have 3 platters, like a Western Digital drive and things like that. But the platters of the old days where we would have 8 platters or 9 platters in a drive, that's being removed, and we're basically getting down to a smaller subset of those drives so that we can try to increase the density and write that data to those drives and get more data on one physical drive. This is a new thing that basically just got patented by Seagate, and their idea is to use heat-assisted magnetic recording. They call it HAMR. And this is a little bit scary to me because as densities increase and I'm trying to do data recoveries, it could be a really big problem, but now they're trying to introduce this idea that the head is now flying too far away from the platter. If we want to read the data better, we need to get the head closer to the platter. So they're introducing an idea that we're going to move the head closer to the platter, but now we've got problems with evaporation of lubrication and things like that. So we're going to try to make it a tougher material, and we're going to heat it up so that we can change that bit and write back and forth to that bit. And so that's why you see that they've got a laser here on the end, and they're basically zapping the area, heating it up, writing the data to it. It's evaporating the lubrication that's on it, which they call nanotubes. So this really is a series of tubes. The nanotubes are the lubrication that's going to fit between this layer and keep that head from touching the platter and doing those things. But that seems really scary to me. I don't know if you guys are scared by it, because just from the fact of, yes, it might increase your density, and they think they can go 10 times the density. Now, they haven't said if they plan to use this in the perpendicular recording mechanisms items as well. So I think we're going to get a mixture of things. But, you know, if you could go to, 2 terabyte, 3 terabyte pretty quickly, I think most of you would buy it, but we may end up 2 or 3 years down the road with some mechanism that is faulty and doesn't hold up to time. So this is the basics of how the operating system reads and writes files. Now, if you're trying to do a data recovery, this is pretty violent. So if you've got a sector, or if you've got something that's wrong with the drive and it's scratched or whatever, and the head is moving over that platter that fast, there's a really good chance that you're going to hit a bad spot, and you're going to try to it'll actually damage the head, and you won't be able to read that data at all. So the ideal method of trying to do a recovery is to do a bit stream type image, where you actually read the data from one end of the platter to the other end of the platter as smoothly as possible. And there's some advantages to that. One of the advantages is that typically you'll know where it fails, and you'll get whatever data you read up to the point that it fails. So if you have some software that you're trying to do, and what I mean by this is things like DD Rescue, and imaging programs, forensic imaging programs, those types of applications will try to read the bit stream sectors rather than the OS. They're not looking at the files, and they're not looking at how things are physically on the platters. They're reading it from beginning to end and trying to image it. And coincidentally, if you're doing a RAID, you have to do this. There's no other option. There is no OS. You got one bad drive in a set of drives. You're going to have to image that drive, and you'll probably have to image the rest of the drives that you have that are good to try to reassemble them into some manner with software or whatever else that you can do. And there are pieces of software that can reassemble RAID and try to guess things and work things out. And as you can see, for the most part, I'm trying to address the physical problems of a drive regardless of the OS. So it doesn't matter for the most part what OS you're using. If you're imaging a drive and you're doing a DD, it doesn't matter if you're using Windows to read a Linux drive or using Linux to read a Mac drive, things like that. So you're trying to narrow down what your scope is going to be so that it doesn't matter what kind of errors and what kind of things that you can have going on. And most of the recovery programs that are out there try to read a drive as if the OS mounted it. So that's kind of a bad story when you're looking at how most of the recovery software works, because if it's scanning the drive and it's moving around with the files, or it's trying to skip around on the platters, it may be causing more damage, and you may use up the 1 or 2 good times that you have left to try to get this data back. And most of the time, that's a pretty big deal, because I will tell you that on a damaged drive, it really matters that first time or that second time. There's people who keep trying, they'll plug it in and one day it works, the next day they plug it in and it doesn't work, and so on and so on. you're using up your last few chances to try to get that data back. So once you know that a drive is done, you need to be prepared to try to copy those files off in the easiest fashion that you can. So I'm going to go into some of the basics of trying to actually do the data recovery and reassemble a drive when there's a problem. In the years that I've been doing this, the numbers have pretty much worked out like this. 85% of the problems, at least for that first round, even if it's a physical problem, a lot of times you can read it with software. And you may need to practice with some software, look at some software. On the website, the myharddrive.com, there is a list of some things that I've tried and worked on. There's free stuff, there's for-pay stuff, there's some discount stuff there. Most of the time, things like DD Rescue and things like that are going to be your first defense to try to go and get that image of that and get something off of it. The other thing is, too, is that you might want to play with some software that when you know what the sector is that's bad, some of the software can actually let you skip those sectors. So you can pretty much say, I want an image from this sector to that sector, and then stop it and get that image, and then start at the next sector. And if the head can move past that, then you can read from there to the end of the drive. And then you can use carving software and forensic software. And, you know, a lot of times people kind of skip forensic software when they're doing a data recovery. And that's kind of a bad idea because there's some good stuff out there that's free, there's good stuff out there, and there's a lot that's for pay. But, I mean, Encase and things like that get up until like $3,000 to do a data recovery. But you don't need that stuff 99% of the time to actually just get your data back in some sound manner so that you can recover the files. So this 15% of hardware, this is the breakdown of what I'm looking at for 15%. The electronics is the biggest one. The board that I brought up at the beginning, where the board fails, you'll get a clicking noise. Sometimes the clicking noise can be two things. It can actually be physical head damage, you know, can't read it off the platter, and then the rest of the time it ends up being a board. A board got fried. Static electricity is really bad around hard drives. Most hard drives are fairly durable. People plug them in, unplug them. They don't use static guards as much as they should, things like that. But that is the biggest killer and kills that board right away. So typically, if you haven't had any signs that your drive is dying and you moved it from one system to another, that's typically what happened is you got some static electricity and shocked that board and it died. And it seems to me, and I'm not going to pick on any particular manufacturer, but my numbers so far seem to indicate that Western Digitals get fried more often from static electricity than they do by physical damage otherwise. Other drives, when I actually get them in for recovery, the board seems to be fairly resilient, but you know, they actually have a physical problem or some damage or something along that line. So just be a little bit more cautious, use your anti-static stuff, and do what you need to do. But already, just because I just told you, 85% you can do that first pass with software, and 10% you just got to hunt down this board, you've got a 95% chance now of getting back your data without having some physical problem or, you know, doing it some other way or shipping it off. So the heads and the platters, I put those together because most of the time that's what happens. They get together, and when that happens, that's where the bad news comes from. And then the 1% is your motor, and that's really bad news. So here's my rules when I'm training one of my guys and trying to get them up to par. I've got 8 guys that are trained to do recoveries, and they take systems apart, blah, 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 and so on. The first thing is not to be emotionally attached. So if it's your hard drive, sometimes you're going to be a little more emotional than you need to be. And the truth of the matter is, you do not need your porn back this week. You can live one more week without your porn. So you need to be a little removed from that and go get new porn from someplace else. Damaged hard drives do not do the same thing twice. And I quite literally mean that exactly the way that says it. That one day you'll plug it in and a damaged hard drive will work. The next day you plug it in and it doesn't. And it goes back and forth. But like I said, you have a limited number of times that when you plug a hard drive in to do a recovery that